Thank you. Thank you. You can see the full screen, right?
Yes.
Perfect. Yeah, Gus, thank you very much. This was a very inspirational lecture from you. And as you suggested at the end, what I'll be talking about is basically the foundations for taking, anyway, the information from the inspection to future for the buildings, maybe. So there are a few parts that I'll also mention about that. So now today, I will be talking about Heritage BIM. This will be a crash course, so I'll really quickly go through some slides. But we will have extended lectures in the summer in Ivrea for both groups. Okay, so so bear with me. I might be too quick, but as I said, we will do hands-on, let's say, experience on Heritage BIM when we select the building in Ivrea and work on it. So, but this will be more about Faculty of Architecture building, which we will host you when you come over to Ankara. So, why do we need heritage information management? Now, the issue is that we have a lot of cultural heritage around us, and they have this universal value that we must basically carry to future generations. But the problem is lack of documentation and technical information and the historic buildings in that regard are difficult to manage. So when it comes to project management or like for future, let's say, future needs, we have difficulties, and there are many lost opportunities in that regard. And maintenance is expensive. It's very difficult. So we need to collect and manage the heritage information in an intelligent and sustainable way. Now, if you want to define what heritage BIM is, basically, we have now tools to model existing structures by means of new technologies. We can create full three-dimensional models from remotely sensed survey data like laser scanning or digital photogrammetry. And BIM, maybe I should quickly tell you what BIM is. BIM is basically representing the built environment in a three-dimensional and semantically rich way. And in that regard, we use model-based representation. We use objects which are based on international standards. Okay, and the whole idea is that to streamline the design, construction, and operation processes, where we can transfer information through different stages, through different life cycle phases by means of these objects. Okay, so there are many different software tools, there are many different processes, but at the end of the day, we are trying to, capture and keep information and transfer into the future in terms of new built environment. But when we talk about existing structures, like historic structures, we use laser scanning or digital photogrammetry to capture the 3D model, but this model needs to be reverse engineered. Okay, so we basically create an as-built reality from that digital scan. Okay, and then we create a semantic model from that. We basically go beyond simple 3D visualization by creating intelligent objects where we can include construction methods, material makeup, and conservation status of the buildings. So, as you can see here, let me quickly switch to pointer laser. Yep. As you can see, with BIM, we design a new building, we build it, we operate. So we use that model for that. But with Heritage BIM, we survey an existing building, we create a point cloud, okay, and then from point cloud we create models, and that these models are used for managing the heritage conservation information, okay. So in that regard, the heritage BIM is a relatively new field. The term was only coined like 15 years ago in 2009. So it's a very fresh field, and there is no one way of doing things. Okay, so many different, let's say, researchers are doing taking different aspects of heritage BIM and in looking into it. So, for instance, we look into diagnosis and we integrate into heritage BIM like structural assessment, decay mapping, decision making for retrofitting, which we will do in the summer. So this is what we do. Or we convert the damaged model into as-built model. We can look into deformations, cracks, material weathering, and basically we integrate more and more data and information into the BIM model that we create for the heritage. Okay, so in the past we were using only 2D CAD. 3D modeling came with the digital scanning technologies, but the problem is that that model is still like very intensive and a lot of points and difficult to materialize, understand. We have heritage BIM where we basically can integrate different pieces of information, linking it into objects, spaces, in time, era, different things, and we can even create automated diagnosis, structural health assessment, just as Gaz has mentioned, where we can integrate, for instance, sensors into the building and carry that data to the digital model, okay, and have an automated IoT-based system where we can have AI-based predictive maintenance in the future. So how does it, well, what is the problem here? This is something still, being discussed and very difficult. We will experience it in the summer too. We have raw survey data like point clouds, okay, and we need to convert it to semantic BIM objects, okay. So the issue is how do we automate that process? So this is something that we will be looking into this summer. Most of the stuff is still done manually, which we will do. But yeah, it's a field that's still in discussion. So the point cloud is basically very complex. It's very like in terms of the data intensity or like the data, the cost of data resources is huge. Okay, it's very detailed, but it's very difficult. We convert it to triangulated surfaces like mesh surfaces. This is what we do first. Okay, it's still very complex, but it's a little bit better than point cloud. But semantically, it's still low. Okay, what we do is then we try to create parametric beam objects from that triangulated mesh. And the way we do that is we basically create shapes, rule-based shapes. We sacrifice detail, but these rule shape base are very useful in terms of having a beam model which is manageable. Okay, because when you have like gigabytes of models, it is okay, very detailed, but it's very difficult to deal with. You may still keep that data in somewhere else, and you can still connect to it, but we want something relatively simple, relatively manageable with the existing software packages that we have. Maybe in 10 years, 20 years, we will have hardware and software that could make this shift immediately, automatically, and allow us to go back to high resolution data whenever we need it. But for the time being, we are trying to solve that. How do we do that? Well, there is one problem actually in that regard. The traditional well, I should say traditional because yeah, I think that yes, the day before I was talking about BIM software to my students. Now they are like 20 years old. Okay, no, sorry, 30 years old. The Revit is like from 1997. So the software are becoming really old and traditional, and they, like Revit, ArchiCAD, they have libraries for modern buildings, okay? And they lack historic parametric objects. And the historic buildings have geometric irregularity, okay? So like we have leaned walls, we have uneven floors, you have like unique morphologies, which do not really fare well with standard BIM objects. So researchers are looking into different ways of solving this, like geometric description languages or NURBS tools to bridge this gap. So basically, this is an issue with BIM. Standard BIM libraries, they don't really work. We have to find other ways to represent in BIM environment. But yeah, this is a challenge. The other challenge is how do we enrich these models semantically? How do we create ontologies for that? So if the data does not contain, if the model does not contain the data about the object, its history, its decay, material chemistry, etc., then it is not really useful. With Heritage BIM, we want to integrate more and more into data with that, into model with that. So, but the problem is the heterogeneity of the data. The data is fragmented in that regard. We have text, we have photos, we have oral histories. The standard BIM schemas in that regard, they, like IFC models, for instance, industry foundation classes, they don't have such classifications. So we may need to create our own semantic web or ontologies. So we need to create knowledge graphs where we can manage complex historical relationships between different information sources and the model itself. So, like a wall is relatively simple, but the information, the knowledge that we can integrate into a wall object. Okay, wall object is shared between a historic building and a new building, and it's well represented. It's very easy, but to represent. But like the material analysis, like archival photos, historic periods, the story of the wall, when it was changed, how did it lean, how did it change shape, how it was decayed. This is difficult to integrate, and there are many different research studies ongoing for that. And another thing is interoperability. Okay, so how can we flow data from BIM, for instance, Heritage BIM, into structural analysis? And how can we go from point cloud to BIM? So without data loss, this is another issue. One of the issues are like with BIM.js, people are trying to work in that. This is an emerging field, or virtual reality, augmented reality, or extended reality, like visual storytelling, immersive, let's say, environments. How do we work with that? How do we basically create an integrated Heritage BIM ecosystem? We do reality capture, we create virtual reality, and how do we basically relate these into systems like structural assessments, or how can we embed different pieces of information into such tools? Extended reality, virtual reality, immersive experience, it's very important. Spatial management, it's again very important. So there are many different ways to make these relationships. So we will talk more about Heritage BIM this summer. So this was a very quick crash course. Now, what I will talk about is the building that we will be using as our home in Ankara when you come over. Okay, this is the Faculty of Architecture. Actually, we booked a space right over here, so we will be always using that room and the classroom. And the other classroom that we'll be using is just behind us in that central space. So this is the Faculty of Architecture building at Middle East Technical University in Ankara. It was designed by Altuğ and Behruz Çinici couple between, and it was constructed between 1961 and 63. So it's a masterpiece of modernism and brutalism. Basically, there is exposed concrete. You will see every piece of concrete is a piece of art. There's a lot of concrete blocks, and wood. And the concept for the university in their campus design and in their buildings was a university as a society, and the whole like infrastructure of the university is basically a learning laboratory for students. The significance of the building is that it represents the best of modern architecture in Turkey. So it's a symbol of forward-thinking education. Okay, METU has always been like that, and this is what it is. But of course, there are physical threats. There are a lot of users, daily users. There's harsh climate. There are unauthorized additions like AC units, cables, mezzanine floors to the building. And there is another thing, of course, political legal threats, which is evident in everywhere in the world for the modern heritage. It's not legally protected, especially in Turkey, and we have ideological challenges to modernism. And of course, there's rapid urban growth, which is threatening the campus. So the building, the research on building was awarded by Getty Foundation in 2017, and the strategy for that project was conservation by documentation, because physical restoration is risky and may not happen overnight, and legal protection is weak. So why don't we first make a very rigorous documentation so that we can at least make sure that building has survived. So the project was envisioned or and started by Professor Ayşen Savaş, who will meet us at the end of my lecture, and she will be our also host at METU. So Professor Ayşen and myself, we will be hosting you. We are managing the project together at METU. And the team was composed of her and academic and administrative members of Middle East Technical University. And the project is a conservation planning and assessment project that was granted $100,000 by Getty Foundation and finished in 2013. The project was started much earlier than the Getty grant, but it was finished after the Getty grant. So this is the interesting thing about the project is that there was a very successful heritage BIM implementation. It wasn't me who has done that. My colleague from Middle East Technical University, İpek Gürseldino. Hopefully you will meet her too and her team. And this is the building, the exploded view of the Faculty of Architecture. So we will be mostly in this wing, but the whole building is open to you and you will really enjoy being there, hopefully, and also the campus. And the idea was that the idea for the project was basically having many processes happening at the same time instead of having a, let's say, linear process for conservation planning. So many things were overlapped, like understanding the place, assessing the significance, gathering information. They were all happening in parallel, okay? And this was made possible by means of a heritage building information model, so that the gathering, generating, and analyzing the building data could be integrated into a backbone. Okay, so Heritage BIM was in that regard used as a research medium. Okay, so basically it was not just a 3D model for the building, but it was a central medium for managing the research data. So what kind of data do we have? Well, we have the spatial geometric data like existing drawings, in situ observation, laser scanning, photogrammetry, point cloud manipulation, texture capturing. So all these were about the spatial and geometric data. We also have typological semantic data, like the archival data, work packages data, photographs, recordings, technical documents, basically the history of the building. And we have BIM modeling that was done for, it was used from point cloud and using the point cloud to create a manual model making process. And they created parametric families and they mapped the textures onto it. And the typological semantic data was organized like with hierarchies, filtering, and organization. These were all integrated in the heritage BIM model by Professor İpek Gürsel and her team. So there they used some interesting technologies like smart globes, smart globe families, which I will show. Custom parameters were created, data was integrated. They used Autodesk Revit, okay, and they wanted to create a living archive. Okay, so that's the idea, which integrated the geometry with social and technical history. So yeah, Faro focus laser scanner was used to create the place where we will be together, and the museum and the amphitheater. And scanned original drawings were integrated, like competition concept drawings, application phases, photographs from 1960s. A physical analysis was done for the building, like Schmidt hammer, or they had crack monitoring tools like Gaz showed you, which you will see when you come over to METU. They are still there to basically carry the data into the model. So these are some documents or that they have created. These are the modeling processes, and the building information model was basically created by means of this 3D modeling. So this is the photo of a space. These are the point clouds. A Revit model was created with hidden lines. We have rendering made on the Revit model, and there is this web-based interactive tool, and then we have interactive heritage beam data visualization. Okay, so the library problem is an issue. As I mentioned before, the Revit windows didn't match the unique modernist detailing of the project, so they had to create custom families from scratch to create as-built reality, like again waffle slabs or the timber frames, iron frames. They were all replicated, created as parametric models. Some one-off elements were modeled separately, like this göbek taşı, the tummy stone from the central one of the central spaces, and these were classified as exceptional in terms of their parameters. Okay, so yeah, the team extended the Revit API to add new data classes for conservation. Again, architectural documentation, the probes were integrated, the sensors that were measuring humidity, temperature, cracks were carried into new classes of objects into Revit. Material samples were again carried to Revit. So we basically have a model that is taking care of these pieces of information within its data structure. Okay, now the smart globes, as I mentioned, were very interesting in that regard. So, like the non-geometric data, like crack reports or a 3D model, how do you represent them? In the 3D, how do you represent them? So they use smart globes. These were placed in strategic locations, and when you clicked on them, they would open PDFs, graphs, or photos about that particular location, object, spots, or building. So, yeah, they had many different, let's say, pieces of information. These were integrated. There is another thing, there is interactivity. The model was exported to virtual reality by means of HTC Vive at that time, one of the best VR tools at the time. And also web-based platforms, Autodesk My Hub 360. We still have access. You can visit and see the site at the project site yourselves. Okay, so basically, non-experts like students, staff, or people outside can basically view the model and the data via web browser without need of any specific software. The data is not locked away, it's accessible for decision making and public awareness. So these are the links to the project. So I think I have a quick video of the interactive tool. So basically, this is something that you can visit through the project website. I think I have a link to the project website later. I'll show you. And basically, you can reach certain documents in the project by means of that website. And you can basically move around, click on a smart globe, and then see the contents of that smart globe as you wish. Okay, so in that regard, this shows us that how powerful that tool is by bringing the public into the let's say scene, and also making sure that they also have capability to reach the project documentation. So there are many other pieces of information within the project that you can access. So Also, the model allows for continuous updates, for instance, about the cracks or a new history is discovered. So basically, you can continue adding data and information into the project. Basically, in that regard, it can even potentially shift the conservation from reactive repairs to proactive management based on, for instance, how cracks are happening. It's like a prototype for the whole campus. This is another thing because when you come over, you will see the whole campus is really rich in terms of modernist architecture. So here you can find the report for the project. If you search for Keeping It Modern Report Library for METU, you will be able to find the project document. It's like nearly 500-page PDF file, and you can download freely and see the way the project was run. So I think I will stop here. And if you have questions, you're welcome to ask. The project website we will probably share with you later. So because we are running out of time, I don't really want to continue any further.